Hello, I'm Mark Pollitt, and welcome to Email and Internet Evidence. Hello, this is going to be a brief overview of email and internet evidence, and there are additional videos available on some of the details that are discussed in this video, but for this one we're just going to talk about some general concept. The first thing I wanted to mention is this notion that emails and the web are somewhat old technologies. They're really the first of the applications for the internet, and they date back to the early 1990s. I compare these, I call these Web 1.0 technologies because in large measure the content is mostly static and it's all about applications and the standards developed for applications, and most of it is client-based. Compare that to the current, what I would call Web 2.0 technologies, things like Twitter, Facebook, etc., which tend to be much more interactive, much more flexible, much more fluid, and are primarily cloud-based. The technologies we're going to talk about here are a little bit about email, web, Skype, and instant messaging, or chat in the old parlance. We're going to focus mostly on email and web. Skype and instant messaging are really kind of hybrids of those other two technologies, and we'll deal with them another time. Focus on Web 1.0 technologies is really twofold. One, the application, because mostly they're driven by applications, and two, the data, which is where it stores the particular information that these applications deal with. We're looking for really two parts when we're dealing with these communications technologies. One, we're looking for the content of the actual messages, etc. But we're also looking for what the connections were, what the activity was surrounding the acquisition of those of the content. As an example, if somebody is downloading some data from someplace, clearly we want to look at the data, but we also want to look at where, when, how was that data downloaded. And so from a forensic perspective, we have to deal with both of these issues. The applications themselves really are pretty simple. Applications need to have really three things in them in order to use these Web 1.0 technologies. The first, obviously, is a user interface. Because they're web, they have a graphic interface, and each of them have their own features there. But then they have to have a way of dealing with the particular data, whether it's web data, HTML pages, or chat messages, or emails. It has to have some way of processing those, storing them, retrieving them, etc. And last but not least, it needs a communications protocol in order to get those things from the network. Multiple applications often share a common protocol. And different applications within a particular class share the same protocol. For instance, when you're talking about mail, Outlook, Thunderbird, and Zimbra can all utilize things like POP3, which is the post office protocol, which is one of the most common ways of actually exchanging information or exchanging emails. In comparison, what used to be called Hotmail is now called Windows Live or Outlook Live, I guess now. Yahoo and Gmail are primarily web interfaces, so their actual protocol that they're using is HTML, so they're using a different port from the ports that are being used for the standard POP3, IMAP, or SMTP connections. Now, web browsers, as a class of applications, all share one thing, and that's obviously HTML. Otherwise, they wouldn't be web browsers. Some support other technologies, and some don't. In some implementations, some do and some don't. For instance, Internet Explorer typically requires the use of ActiveX, whereas typically that's not available in Firefox. Typically, Firefox utilizes Flash, which is why it typically doesn't work on things like iPad, which prohibit the use of Flash. Some browsers use XML and deal with it much more natively than others. When I was doing my dissertation and I was interpreting a great deal of XML, I found that Internet Explorer was actually much easier to use and provided much more robust support for XML than Firefox, even though Firefox is my favorite browser. All browsers end up having to store recent pages, and as a result, the files that make up those pages. And so they all have to have a way of keeping track of what pages they've been to. And so they all have a history, and they have a storage of recent files called a cache. But they typically store them differently and very often in different places, and sometimes in different places depending on the operating system that the particular application is written for. For instance, Firefox stores its history and its files in different directories for Linux, Macintosh, and Windows. Usually it takes a particular tool to look at browser histories, although we're going to discuss briefly one plugin for a browser that allows you to look at histories. But typically those dedicated tools look at both the internet history and also allow you to reconstruct web pages. Because after all, it's the ability to reconstruct those web pages that really is documenting the content part of the web browser forensics. Now, doing browser forensics, it's important to understand how the particular application stores data and knowing where it stores it. And having a tool that can read that data is crucial, and not all tools read all browser data and are familiar with the particular setup for each browser. So, you really need to look at those things. I offer 2 pages here, which are articles posted on the Semantic site that really do a great job of outlining browser forensics. And so I won't bore you with that. I offer those links as a suggestion of where you can delve into this a little bit more deeply. And more importantly, that you can use as a reference when you're trying to find data for different kinds of browsers. Email is extremely simple in concept. You have a sender, you have a receiver, you have a client, you have a server, and in its basic form you use a simple mail transfer protocol, or SMTP. There are some a little bit more sophisticated protocols, such as the Post Office Protocol, currently in version 3, so you'll typically see it listed as POP3. Also a typically Microsoft Exchange interface called IMAP. The advantage of IMAP is it allows you to keep stuff both on the server and on the client synced, so you can have multiple clients and see essentially the same setup for your email. But all email is accessed with one of 2 basic kinds of interfaces. One is an HTML interface, such as webmail, Hotmail, Yahoo, Gmail, etc. The other are things like Thunderbird and Outlook, which are client-based and utilize POP, POP3, IMAP, and SMTP. Some tools allow you to do both. Some servers will allow you to do both. For instance, Gmail allows you to download your email as a POP. I'm not sure if it does it with IMAP, but conversely, LiveMail or currently Outlook Live allows IMAP as well as a web interface. The features also will vary by client. Obviously, the client is no better than the features that are programmed into it. So each client has its own peculiarities. Likewise, each client stores the data differently. But one thing that's important, and like browsers, they share the communications protocols and the user interface, but the storage typically with email is some form of database. In some cases, like Firefox, they use a version of SQL called SQLite in order to store the Microsoft folks' Outlook database, their stuff in a proprietary database. So the obvious thing is, in order to look at those, you're going to need a tool that allows you to look at those interfaces. With Internet history browsers, there's some software out there. One of the most commonly used is the Nearsoft stuff, i.e. History Viewer and Mozilla Cache View. I've used them. They're available online for free. There's another one that I have not used, but it looks pretty good. It's called Browser History Spy from Security Exploded. It's given a Norton green, indicating that it's not spyware. I'm always a little concerned about software that has the name spy in it, so I asterisk that just to tell you caveat emptor, buyer beware. There's also a plug-in for Firefox that you can use. Actually, it's an add-in, technically not a plug-in, and it's a SQLite viewer. If you open Firefox and go to Tools and go to Add-ins and search for SQLite, you'll find this viewer. With email investigations, as we mentioned earlier, you really have to understand how the client software stores and manipulates the data for the email. And each of them are different. Outlook has PST files, and Thunderbird uses SQLite. And so you need to be able to decode those things. Fortunately, most of the professional grade forensic suites like EnCase and FTK will do that for you. FTK has a reputation for being a little bit more robust in terms of its abilities with email, but EnCase has come a long way. ProDiscover, particularly in the basic version that is freeware, does not have anything more than very rudimentary abilities with respect to email. So I generally don't recommend that for email investigations. With respect to webmail, things like Yahoo and Outlook Online, etc., you really have to do two investigations. The first is that you actually have to use your browser forensics to identify that there is webmail in play here. Because if nothing is being stored on the hard drive, the only record of that is going to be in the Internet history and the Internet cache. And so as soon as you identify that, you need to advise the investigators so that they can get a subpoena or search warrant in order to get the data on the webmail server, which is probably going to be where most of the evidence is going to be. And the sooner that you can let them know about that and get them on their way, the more likely it is that data will not be overwritten or purged. Well, that's a very short presentation on Internet browser forensics and email forensics. I hope that you found the lecture useful. There are additional videos available with some of the details on how to do some of these things, and you will likely have, as part of your course, a set of laboratories and or examinations. So look for those. And until next time, have a good day.